In 6.2, we are going to now transition and take those proportions that you learned about in 6.1, and we're going to apply it directly to shapes, polygons, triangles, quadrilaterals, pentagons, things that may or may not be regular. And what you need to know is that this symbol right there, this little wavy symbol, means the word similar. If you ever see me write that down, it means that these two shapes are similar. Similar means that they have angles that are the same. All the angles are going to be congruent to each other. And the sides are proportional. They're going to be in the same ratios as each other. So with that being said, this whole unit is on similarity. When I think about all of chapter 6, that's what I would call this chapter, is similarity. And so dealing with proportions, 6.2 is how do we know if things are similar or not similar? If their angles are congruent and their sides are proportional, they are similar. These things are called similarity statements. Similarity statements is when you say one object is similar to another. It has that little wavy symbol again. When you see a similarity statement, it can be written in a variety of different ways. If I wrote FHG, then that would have to match up with MPN. The reason for that is that these angles match each other. These angles are congruent. H is the third letter. P is the third letter. They are congruent. They're the exact same size. The angles are the exact same size, but the sides are not. They're proportional to each other, which is why if ever I'm dealing with a proportion, I can look at, like, let's say the first and the last. Let's just say FH is the first and the last. That can compare to the first and the last of the second triangle. I could come up with a bunch of proportions based off of the similarity statement, using 3 things I know and 1 thing I don't know in order to find a missing side. That's how I use it, just so you know. Okay. Next thing is something called the scale factor. The scale factor is the ratio in simplified form, meaning reduced to lowest terms, of the corresponding sides of similar polygons. Our textbook's a little bit funny. Sometimes it doesn't say what order to give it in. So what you will need to do is, if there is a picture like this and this, and they say, what's the scale factor? You will use the left side compared to the right side every single time. Left side compared to the right. But normally what our Clovis Unified's policy usually is we're going to say, what's the scale factor of DEGH to PLQR? I will actually say what I want you to do it, the larger to the smaller, or the left to the right, and so on. So the scale factor is basically what is that ratio in lowest terms. Make sure you do that. If it doesn't say, do the left compared to the right. You can use that scale factor to find missing pieces by setting up proportions. That's really all the math that you're going to be doing throughout this section. The reason I wanted to highlight 2 other things before we got into examples were the overlapping triangles and the twisted triangles. Here's what I want to show you. Let me give you a quick example for overlapping triangles. If you had something, let's say like this, 2 and 1 and 3 and 5. 6. X. Can't make up my mind. When you're dealing with overlapping triangles, you have this triangle on top of the other triangle. They're going to try to trick you, especially when they do not give you full distances. They do give you full distances, but it's disguised. If you are setting up a proportion for something like this, keep in mind the small left side of the triangle over the small bottom would be like a 2 over 3. That would be equal to, what's the big left side going to be for this triangle? If you know, say it out loud. I can't tell you how many times people will just put the 1 because they see a 1, they're going to try to put a 1 there. Keep in mind, left side of the small, left side of the big, you might have to add 2 pieces together to get that in an overlapping triangle problem. The bottom on the other one is x, and so 2 over 3 equals 3 over x is how you would set it up correctly. Make sure you pay attention to full distances versus not full distances in the problems that you're setting up. And twisted triangles use the similarity statement. Sometimes you're just going to need to look at this statement to set up your proportions. The way the twisted ones work is a lot of times you'll have a small and then they might twist into a big one, something like this. It's where one triangle doesn't match up per se. I'll show you. If this was x, the x would compare to this side over here. Let's call that 5. And let's call this y, and then this would be 7. The y and the 7 would match, and the 5 and the x. They twist, and their sides match. And how would you know that? Because the vertical angles are the same. The 90 and the vertical angle, this is the side between it. The 5 matches up with that. Same with the hypotenuse and the other hypotenuse. Keep that in mind. They are going to try to trick you by how they show you the triangles. Okay? Let's get into some examples. First example, this is in your book. Feel free to get your book out if you would like to do it with me. You can. This is number 13 in your textbook. It says, are the polygons similar? If they are, write a similarity statement and give the scale factor. Right angle, arc, 3 arcs, 3 arcs, 2 arcs, 2 arcs. All the angles are congruent to each other. Are they similar? Most likely. Let's check to see if their sides are proportional. I'm going to check and see by doing, let's see, 24 over 16. I'm going to check that. I'm going to check 24 over 16. It's the same thing. 18 over 12. And the right side is 12 over the right side, which is 8. I'm just going to check these things and reduce them. I'm going to divide these by 8. And that goes in 3 and 2. I'm going to divide that by 8, which is 3 and 2. I'm going to divide this by 6. Which is 3 and 2, and I'm going to divide this by 4. And what you'll notice is that when you compare all the sides, they all reduce to the same value, which is 3 over 2. That's called the scale factor. So let me answer these questions. Are the polygons similar? Yes. If they are, write a similarity statement. The first statement can be any 4 letters you want. D, E, G, H. But as soon as you write D, E, G, H, then what you have to do is make sure that it matches up with the other one. If D is your first letter, D better be congruent to P, L, Q, R. They need to match. That's what that means. This is a quadrilateral. So we do not know. There's no shape in front of the quadrilateral. If they are, write a similarity statement. We've done that. We've done part 1. Here's part 2. And give the scale factor. The scale factor, you can give it in any way you want. You can give it as a fraction or as a decimal. Not as a decimal, but or with a colon or with the word 2 in it. And I prefer the fraction, but I would accept it this way as well. Next example. I'm going to do number 19, 22, and 20 with you based off of the questions that I got off of first period. It asks, what's the scale factor of HKM to DFG? Notice that they tell you that the first triangle is the smaller one, and the second triangle is the bigger one. They're asking you to find the scale factor from the right compared to the left. You have to go in that order because it gives it to you that way. It also tells you in the beginning that they are similar. Hey, these are similar to each other, so now we have to find everything else. So we need to figure out this one compared to this one. And the only two sides that I know are the same as each other. HK is going to be similar to DF. HK is 18. So I'm going to put number 19 right here. HK is going to compare to DF. HK was 18, and that is going to compare to 30. This reduce, divide by 6 is 3 over 5. And so our answer for number 19 should be 3 to 5. And generally, if they ask it with the letter TO in the between, the word in between, I will write it in the same way it was given. This is 3 to 5. Number 20. What's the measure of angle K? Well, K is going to be the exact same as angle F. These are going to be congruent to each other. When they're similar, the angles are exactly the same. So what does that tell me? That tells me that if this is 59, then this is 59. If this is 70, this is 70. So to find angle K, all I have to do is add these two up and subtract from 180. Has anybody done that already?
51.
51? Do we agree? Okay. Just going to add 51 plus 59 plus 70 to double check, and it works out correctly. Lastly, it says MK. That's this value right here. We don't know what it is. I'm going to call it X for right now. What we could do is we could use our scale factor to set up a proportion to figure out how big MK is. Since we know that these are in the ratio of 3 to 5, I can just write 3 to 5 is equal to, remember, this is small triangle to big triangle. Small triangle is the X. The thing I don't know, MK compares to GF, 27.5. I'm comparing this to that, but that in lowest terms. Now I'm going to cross multiply. 3 times 27, 3 times 27.5 is 3 times 27.5, 82.5. And that's equal to 5x. Divide by 5. Divided by 5 is 16.5 is what I'm getting. MK equals 16.5. Last example. Find the value of x and give the scale factor of the polygons. It tells you that they're similar. I see that both of these are isosceles, and I have an x, and so this is an x. And if I'm trying to set this up, I have to look at this similarity statement to figure it out. BV is going to be similar to the LJ. I can say 5 over x is going to equal QV over, QV is over WJ x plus 6. If you set yours up x over 5 equals x plus 6 over 8, that's totally fine. What I would do from here is I would cross multiply 5 times the x plus 6, and I would do the 8 times the x. Do not forget to distribute, which is the most common mistake. Find the value of x. We have x is equal to 10. Then it says give the scale factor of the polygon. So to do that, we have to plug this back in. This is 10. This is 10. This is 16. And if you compare, give the scale factor. It doesn't say the order, so if it doesn't say, I'm going to do the left one to the right one. This is 16 compares to the 8. The 10 compares to the 5. The scale factor is going to be, let me just write 16 compares to 8 or 10 compares to 5. The scale factor is going to reduce in lowest terms 2 to 1. And that's where we're going to stop your notes for today.